Hey there, fourth grade. This is Mr. Campbell. Today we are going to be getting started on page 93 in your math book. So go ahead and turn with me right now. We're going to be doing lesson 3.4, use area models and partial products to multiply. And at the end of this lesson, we want you to be able to say, I can use area models and partial products to multiply. Well, we're going to talk more about what does that mean, how does that look, and we're going to be using some vocabulary words. So actually, we're going to turn to page 94 right now to check out our vocabulary words and how this is going to work. So turn with me. All right, here's page 94. And again, if you haven't got there yet, go ahead and pause the video, get to page 94, because we're going to be taking a look at some of the words and vocabulary here. I want you following along with me the best that you can. So I already see I've got some of these yellow highlighted words. There's one more right down here too. Those are going to be important vocabulary words for us. All right, so as we read through today, we're actually going to start there and read what are those different ones. So our first one says a numerical expression contains numbers and at least one operation. 8 times 25 is a numerical expression. Numerical expression. Numerical sounds like number, right? And so this is an expression, just means an equation, something like that. And so an expression that has one operation. Operations are going to be addition, subtraction, multiplication, or division. So a numerical expression is going to say we're going to have numbers and we're going to have one operation in there to create our numerical expression. All right. The next one we've got over here is area model. It says you can use a rectangular area model to show multiplication. The product of 8 times 25 is the area of the rectangle. And if you remember, area means how much does it take to fill the inside of a shape. And so for this one, we've got our rectangle. So we're talking about how much actually fills that up. All right. And then we're going to come down here. Letter C. The distributive property says that multiplying a sum by a number is the same as multiplying each part of the sum by that number and adding the partial products. All right. And so you might be saying, that's a lot of words. I'm not real sure. Look down here. 8 times 25. Well, this is the same as saying that if we took 25 and broke it into its two different place values, 20 and 5, and multiplied those each by 8, and then added it all together, it would still give us the same answer. These are equal. And whenever you see something written out like this, we've got some on this side and some on this side with that equal sign, that's what it means. It means they're the same. All right. So here we've got 8 times 25. Here we have 8 times 20 plus 8 times 5. All right. So that's what our distributive property says, that we can use our different numbers to still be able to multiply together. Well, let's go ahead and go back up to box A and let's read this word problem. And as I read it, I'm going to underline the important pieces of information. I'd love for you to do that with me. It says a garden is in the shape of a rectangle. It is 8 feet wide. So I'm going to underline 8 feet wide and 25 feet long. What is the area of the garden? So we took this 8 feet wide and 25 feet long. We used a numerical expression. So write this in with me, 8 times 25. Because when we find area, it is length times width. And here's our width. Here's our length. Well, for box B, it says, what are we going to show? Well, if we want to draw a picture of this, so we drew our rectangle here. We took our 25 long and made the longer one 25. And we took 8 feet and did the side over here. So we have 8 and we have 25. All right. Now, it says we can use this area model to solve that kind of a problem. Well, the next piece that we've got is we decided to break it into our two place values. So here's my 20 and here's my 5, 20 and my 5. I took the 25 total and broke it into those two pieces so I can kind of chunk it together. Well, down here, we're going to go ahead and check out what do we have. All right. So here I've got my 8 times 20. All right. And that's because up at the top, we had 8 times 20, right? So here it is. 8 times 20. Well, 8 times 20 is 160. And then I need to do my second one. 8 times my 5. 8 times 5 8 times 5 is going to be 40. So I've got this 160 and I've got my 40. All right, 160 plus 40, because the distributive property told me I can take my 8 times 25 and break it into 8 times 20 and 8 times 5, but then I need to make sure that I add those together. That plus sign is super important. So what are we actually going to write down? All right, this all looks good, right? But what do we actually write down in a problem like this? Well, 25 times 8, that was the problem we just had. We said 8 times 5 was 40. There's my ones place. I said 8 times 20. 8 times 2 was 16. And it's in the tens place, so I put that 0. And now I add those together to get 200. And we actually call this square feet because when we're multiplying base times length, or base times height, sorry, or length times width, depending on how you want to say it, square feet. So these are how many squares we could put inside of that. So this is what we're actually doing. This is what it looks like. And if you remember, this is our partial products right here, because we're breaking apart the ones place and the tens place and then adding it all up. Let's turn over to page 95 and check out what else we've got in this lesson. All right, so on page 95, we're going to look at another example. And up here, we've got 5 times 123. All right, 5 times 123. I'm going to zoom in just a little bit more. All right, so what they did is they already drew our box for us here. And we took our 120 and 3, broke it into each of those place values. All right, so I've got my 100, my 20, and my 3, and I'm timesing it all by 5. All right, the distributive property tells me I can do that as long as I add them all together at the end, which is what partial products is. All right, so now I can do some easier numbers because I've broken them into each place value. So they wrote each of those expressions, those numerical expressions, inside of each of these boxes. So we start off with 5 times 100, because that's what we've got here. Then we've got 5 times 20, and then we have 5 times 3. All right, so those are our 3. When we do that, 5 times 1 is 5, and I see I've got my 2 zeros, right? And so I got to bring those over. I've got 5 times 2 is 10, but I need 1 extra 0, which is why that's 100. And then I have 5 times 3, which is 15. All right. Once I've done all of that, I'm not done with my partial products, though. I need to come over and actually add it together. This is the part where it's super important we line up our place values. I don't like the way this looks right here because I want my place values always lined up. So I start with my 15. The 5 is in the ones place, and then my 1 in the tens place. I go up to my next place value, which is going to be 5 times 20, which is 100. And then I've got 5 times 100, which is going to give me that 500. Now I can add all these together. So 5 plus 0 is 5. 1 plus 0 plus 0 is 1. And 1 plus 5 is 6. So my answer would be 615. Okay. Now, this is what we're practicing for today. If you don't like the area model, if you don't like partial products, if you just like to be able to multiply, that's okay. But today we're going to practice this way. All right. And the reason we're doing that is just to give you some extra chances to say, all right, well, how's this going to look? So let's look at number 1. It says, what numerical expression is shown by the area model below? When they're asking for the numerical expression, what they're saying is, well, what's the actual equation that I'm going to do? All right. And so when I see this, I go, okay, I've got all my different pieces up here. I need to put those together. So 200 plus 60 plus 5. That means I've got a 5 in the ones place, a 6 in the tens place, a 2 in the hundreds place, and I'm multiplying all of that by 7. This is a part you should be writing down with me. So you should have your pencil in your hand. You should be writing in 265 times 7. Well, now we're going to go ahead and go through and actually multiply. Let's figure this out, find it out. All right. So here, just like we did in our other example, I'm going to do 7 times 200. Here, I'm going to do 7 times 60. And then here, I'm going to draw a little arrow down here because there's just not a lot of space in there. So I'm going to do 7 times 5. All right. So I've got my numerical expression over here. And now I've written in my different parts. Well, let's go piece by piece. 7 times 200. Well, 7 times 2 is 14, and then I need 2 zeros. And when I do this and I'm writing this, I don't like rewriting over and over again. So I'm just going to make sure as I do each of these, I'm going to make sure that they go in the correct place value. All right. Now I've got 7 times 60. Well, 7 times 6 is going to be 42, and then I need a 0. So 0 and then 42. My last one is 7 times 5. 7 times 5, well, that's 35. So 5 goes in my ones place, and a 3 goes in my tens place. Again, I hope you're writing all this down. This is what you're going to be practicing today. Once I've done all of that, I can add this up. 0 plus 0 plus 5 is 5. 2 plus 3 is 5. 4 plus 4 is 8. 1 plus nothing is 1. So what is 265 times 7? Well, it's 1,855. All right? That's how we're going to do it. I'm going to have you practice number 2 on your own. You need to make sure that you write in our 2 different equations from this. All right? Just like we did over here. I took my 7 and times it by 200. So ask yourself, what are you going to multiply here? What are you going to multiply in here? And then make sure you add it all up. Put your final answer right here. Pause the video and solve that now. I hope that you paused the video and worked on that problem. I'm going to go ahead and walk through it right now. All right. So here I've got 7 and 500. So that's going to be 7 times 500. And then I actually only have 60. There's no ones place in here. So 7 times 60. I'm going to draw a little arrow and make 7 times 60. All right. Once I've done that, now I can say, well, what's 7 times 5? 7 times 5. Well, 7 times 5 is 35. And then I see I've got those 2 zeros that I need to include. So 3,500. All right. Now I'm going to say, well, what's 7 times 60? Well, I can start with just 7 times 6, which we did in the last one, is 42, but I need 1 extra 0. So I start with my 0, and then I put my 42. Now I can add it up, and look at this. I like to make my little green bar my equal sign. 0 plus 0 is 0. 0 plus 2 is 2. 5 plus 4 is 9. 3 plus nothing is 3. So my final answer here is 3,920. All right. That's how we can solve each of these. Now I want you to do one more with me. So we're going to actually slide down here to number 5. All right. We're going to do number 5. 3 times 185. All right. Go ahead and pause the video right now. Fill in all your different pieces. And then you can put your final answer over here. Go ahead and do that now. I hope you paused the video and solved that problem because we're going to go ahead and jump in now. So I've got 3 and I've got 100. So 3 times 100. Next I have 3 and I've got 80 over here. So 3 times 80. And then last 3 and then 5. So 3 times 5. All right, I'm going to go ahead and solve each of these. I hope you already did that. All right, 3 times 1 is 3. And I need 2 extra zeros. 3 times 8. Well, 3 times 8 is 24, but I need 1 more 0. And then lastly, I've got 3 times 5, which is 15. No extra zeros in that one. Now I can add these together. 0 plus 0 plus 5 is 5. 0 plus 4 plus 1 is 5. 3 plus 2 is 5. So my final answer here is 555. All right. You would do the same steps for your other independent practice problems, making sure we fill in each of those different pieces. They've already drawn the boxes for you guys. This is pretty easy. We just got to make sure we follow those same partial product steps to be able to solve it. Well, I hope that you've been following along. This is making sense and that you're going to be able to solve these problems on your own. I hope you guys have a great rest of the day, and we will see you next time.